Yes, okay.
Yeah, you did try. Okay, so I think you do this frequency one, right? So number 4. Hello.
Sir.
Did you do this question 4A?
Yes, sir.
Yeah.
I
So
used it in the class.
yeah, how you did that? Yeah, what formula you used?
Speed by lambda. Speed is equal to frequency x lambda.
Yeah, speed equals to frequency multiplied wavelength. So here in this question you are going to find the frequency, right?
Yes, sir.
So frequency will be speed by wavelength, right? Then what is
Yes,
your
sir.
answer?
It came 3.1
And the unit
multiplied by 10 to the power 14.
3.1 into 10 to the power 14. And the unit,
Then do more.
what is the unit of frequency?
Hertz.
Hertz, yes. So you should write their hertz. Okay. And
Mm,
you got here the answer. Can you tell me again the answer?
Sorry, sir.
What is the answer again? Say
3 to the sorry 3.1 multiplied by 10 to the power 14.
so. You got F equals V by lambda, right?
Yes, sir.
And what is your V? What is the value of V here?
3.1 multiplied by 10 to the
Yeah,
power 8.
here this one 4. Question 4. Are you seeing the screen?
Oh, sorry.
Mm-hmm. What is the speed given? V is the speed, right?
Yes, sir.
So what is the speed given here?
0.15.
1.5. Yes. Then wavelength, what is given?
0.030.
Okay. Then if you put in the calculator, what it's come?
Mm, 0.5.
0.5. So your answer is now 0.5, and previously it was big. So you are doing
Yes,
this
sir.
one or you are doing other one?
I was doing the other one, didn't see it.
Okay, okay. That's why this one. So we are now talking about 4A. Yeah, the answer should be 5 hertz. Okay. So it was also easy question, right?
Yes, sir.
Now we are having this one. This question is very easy also. So what is meant by frequency? Question number 2B.
The
What?
number of complete waves per time, per unit time.
Very good. Then wavelength.
The distance from crest to crest and trough to trough.
Yes, distance between crest to crest and trough to trough is wavelength. So good, very good. Then now we try this, part B. Question 1, part B. Uh, you tried it, right? Calculate the frequency of the wave here.
Mm,
It is also like before. You just did 4a, the same formula will use, right here.
yes, sir.
And here is also given the speed and the wavelength. So you put the values over there, do the working. You have this worksheet printed, right?
Yes, sir.
Okay, very good. Now do it. So our formula is F equals, what is the formula? F equals
F is
V
V
by
multiplied by
V by
V
lambda.
divided.
V by lambda. Yeah. F equals V by lambda because we have V equals F lambda. So if you rearrange, it comes F equals V by lambda, right? Frequency will be equal to speed divided by wavelength, right? And the
Yes,
value of frequency, the value of speed is given how much? 0.17, right?
yes, sir.
And value of wavelength is given 0.019. 0.019. Okay, then what is coming? Check.
8.94.
Yeah, you have 8 point
8.94.
8.8,
8.94.
8.94. Then after forward,
There is 7.
okay, then you will write. If you write in two significant figure, then it will be 8.9. If you write in two significant figure, then it will be 8.95. Okay, as after 4 there is 7. Is it clear?
Yes, sir.
Then the unit should be hertz, right? So
Yes,
let
sir.
me check your answer is correct or not. Okay, it is question number 2. Yes, correct. Your answer is correct. Very good. So we are done with this one, right?
Yes, sir.
B1 we are done. Now we are going to next one, that is B2, right? Can you read B2? Can
State
you
what happens to the frequency of the wave as it passes into the right hand section of the tank.
state? Okay, so it's going from left to right. Yeah, from left to right it's going. Then what happens to the frequency of the wave? What happens to the frequency? You got one rule, right, about frequency? Hello?
Mm, yes, sir.
If it is going from one place to another place, the frequency remains always same, right?
Yes, sir.
Frequency always constant. So what should be your answer? Frequency is same, right?
Yes, sir.
Frequency is same. Frequency does not change. Then have you written?
Yes, sir.
Then next, part 3, read.
Using figure 1.1, state and explain what happens to the speed of the wave as it passes into the right-hand section of the tank.
So what will happen to the speed? It's going from deep to shallow, right?
Yes, sir.
Then
The
what
speed will
happens?
increase.
If it is going from deep to shallow, then what happens? Increase or
Um,
decrease?
increase.
No, no, it's decrease. If your wavelength, you see the wavelength is now more, right? When it is going
Yes.
to right side, the wavelength is becoming small. So what is your formula? Formula is V equals F lambda. Frequency is constant. Your lambda is decreasing. So speed should also decrease, right?
Yes, sir.
Yeah. So is it clear?
Mm-hmm.
Now what you'll write? What you'll write, Monica?
I wrote deep to in the tank. In the tank, the wavelength from deep to shallow will decrease.
Yeah. The speed will decrease as the wavelength decreases, right?
Yes, sir.
Here wavelength decreases. So you try more questions. You try from here more questions. I'm giving you here 3 minutes time. Okay.
Mm.
The gap you got how much?
In real, the gap is 8 centimeter.
Yeah, in scale, how much you got? In
Eight
your scale,
centimeter.
yeah, take how much you got. Yeah, the gap between these
It's
two, how much you got? Can
it's
you tell me,
it's
please?
8 centimeter.
No, you this gap like between two lines. What is the gap you got? That one I'm asking. With your scale, take
Four centimeter.
4 centimeter. It should not be
No,
4 centimeter. You
five, six,
yeah,
six,
with your ruler, you
six.
with your ruler you find here the gap between these two.
Oh,
You
between these two.
hmm, that is giving your wavelength.
It's 6 centimeter.
This two gap. You got your worksheet printed, Monica.
Yes, sir.
So if you use uh, your ruler is giving you centimeter scale, right?
Yes, sir.
So and the smallest unit is millimeter, right? That is 0.1 centimeter, isn't it?
Yes, sir.
So if you place here the ruler, so how many centimeter? It should be not more than 1 centimeter, and after that there will be some millimeters, and then 1.1 1 point some millimeter will come. Okay, 1 point centimeter. So what is coming? Okay, gap. I'm saying the gap, not the length. This length. No,
Oh, sorry.
we are saying about the gap. In between these two lines, the gap we have. With your ruler, you take.
1.6.
Is it coming 1.6?
Yes, sir.
1.6 is too much. It should not be 1.6. It will be
Let me check.
less. Check. Like after 1 centimeter, how many lines you are getting? Check.
1, 2, 3, 4. 4.
Yeah,
It's 4.
it's 4. 1.4. That means 1
Mm-hmm.
centimeter and 4 millimeter, right? That means 1.4
Yes, sir.
centimeter. Is it?
Yes,
Yes,
sir.
it can be 1.4 or in between 1.3 and 1.4. So exactly what you are getting, that one you say me.
Okay. 1.3 is exact.
1.3
3.
is exactly you are getting,
Yes, sir.
or in between 1.3 and 1.4.
Yes, sir.
What you are getting?
1.3.
One.
1.3.
Okay, you are getting exactly 1.3. So right here, yeah, this way in your space here we write this way. Wavelength. Wavelength is equal to 1.3 multiplied 8. So in real life, it is 8 times, right? That means the scale is given 1 is to 8. That means in real life it is actually 8 times. So it will be 1.3 multiplied by 8. What is the value? Check. 1.3.
10.4.
Yeah, 1.3 centimeter, right? Then multiplied by 8. Then 10.4.
4.
10.4
Yes, sir.
should be centimeter. Okay, you got your wavelength, right?
Yes, sir.
Now they are asking you to calculate the speed of the wave in the deep water. So in deep water you got the wavelength and the frequency is given how much?
3.6.
Where is frequency given? At the top, right? Here,
At the question.
3.6. So our formula of speed we know. Speed equals
Frequency multiplied by lambda wavelength.
wavelength. Very good. So speed equals our frequency we got how much? 3 point, what is it?
3.6.
3.6 hertz, right? 3.6
Yes, sir.
hertz, and our wavelength is 10.4
10.4.
centimeter. So we write here 10.4 centimeter, and this one is hertz. 3.6 hertz. What is hertz? Hertz, hertz you can say hertz or per second. Okay.
Okay.
So uh, frequency has the unit hertz. We can also write it this way, per second. Okay, that means 1 by second, isn't it?
Yes, sir.
The formula of frequency is number of complete waves every second. That means your answer is coming, the unit is coming as per second. Per second in short we write as hertz. Okay,
Okay.
so your value of speed, what is coming? 3.6 multiplied 10.4.
37.4.
37.4. Okay, you write here 37. Okay, 37.4, and the unit is getting centimeter per second. Got it?
Okay. Yes, sir.
In your unit of speed, you cannot write hertz. There you have to write in second, per centimeter per second or meter per second, right? So
Mm-hmm.
how you are getting that meter per second or centimeter per second? That one I am showing you here, right?
Mm-hmm.
Is it clear?
Yes. Yes,
So,
sir.
this way we are getting the solution of this part. So can you send it to our group, please? This one.
Done, sir.
Yeah. Thank you so much. Thank you so much. Now our part is done. Now again we go back to our two, question two, which one I told you to draw, right? This one, frequency definition, wavelength definition, you already told me, right? And
Yes, sir.
what you said about frequency, wavelength, I heard it, it is correct. Now
Mm-hmm.
describe what is meant by wave motion in a ripple tank. So what you wrote about this?
Sir, I skipped this one.
You skip this one. So you you got the definition of wave, right?
Yes, sir.
So in that definition, what you got?
Um, Propagation of disturbances that carries energy from place to place in a regular or organized way is called wave.
Very good. So here we are getting propagation of energy, right?
Yes, sir.
Propagation of energy by the disturbance of particles, right? So
Yes, sir.
here they are saying about ripple tank. So ripple tank is water wave, isn't it?
Mm-hmm.
Ripple tank
Yes, sir.
is water wave. So water wave is transverse wave. This one you know, right?
Yes, sir.
And in transverse wave, the particle's vibration is perpendicular with the energy transfer direction, right?
Yes, sir.
Particles vibration. This is one thing. Another thing you know, uh, at the beginning of this topic, we learned that wave transfer energy without transferring matter, right?
Yes. Yes,
Without
sir.
transferring any particles, isn't it?
Yes, sir.
So we will bring that idea here because they are giving you 2 marks. So we'll write the energy transfer uh, in transverse mode and without transferring matter. Okay, so we write here, I'm writing here, you also write, wave motion in ripple tank. Ripple tank is the transfer of energy in transverse mode. You write transverse mode. Why transverse mode? Trans Transverse mode. Why? Because it is water wave, right?
Yes, sir.
Isn't it? Because water wave, we know it is transverse wave, sound wave is longitudinal wave. So in ripple tank, the transfer of energy will be in transverse mode. Transverse mode. Now, without transferring matter, right? Is it clear?
Yes, sir.
So our this part is done, right?
Yes, sir.
Okay. Now, please take the snap of it and send it to our group. This one uh, we need it. This note we need because for 2 marks the answer should be this way specific. You should mention without transferring matter, and you should mention this is transfer of energy in transverse mode.
Done, sir.
Hmm. So this part is done. Now in question number 2, I told you to try part C. Can you read this part, please? Read it, please.
C. A water wave in a ripple tank strikes a barrier. Figure 2.1 shows some of the wavefronts of the incident ray.
Hmm. So this diagram we
Draw
have to
the
draw.
reflected
Hmm. Yeah. Here you continue.
The water wave hits the barrier and is reflected. Three of the wavefronts in figure 2.1 have already hit the barrier. The reflected parts of these wavefronts are not shown. On figure 2.1, draw the reflected parts of these three wavefronts.
So here one thing is clear to us that here we are getting reflection, right? Reflection of the
Yes,
wave.
sir.
And when there is reflection of wave, how we are getting? How we are getting it? We have look. We are getting in our classroom the notes. You also got these notes written in your copy. Uh, I think you have drawn the reflection of wave, right? That part.
Yes, sir.
So in that part, I'm also showing now in your notes so that you can understand it clearly. You see, in our reflection of waves, this is worksheet, and we have also notes, right? Yeah, notes on general wave properties. Yes, this one. So here we got, right?
Yes,
this
sir.
this idea what we learned before. We got here angle of incidence. We have the incident wave. Yeah. So in our question, they gave us incident wave. Hmm. They gave us wavefronts, wavefronts of the incident wave. Now we have to draw reflected waves, right? They
Yes,
said
sir.
draw the reflected parts of these three wavefronts. Yeah. So these wavefronts are from incident wave. And for reflected part, you see what you have to do first. You should draw the normal, right? This way you
Yes,
draw
sir.
one normal first. And after drawing the normal, you take how much angle is creating. It is I. And you should draw reflected wave direction with this arrow first, maintaining the angle that is R. I equals R. Okay, first you draw this reflected wave. Then after drawing is done, you take this, uh, see, lines. The lines we have here, you see, in between two lines that is wavelength, right? So when we are drawing lines here, we should also keep the same gap because when is wave is reflecting back, that time the wavelength is same, speed is same, right? Hello.
Yes, sir.
If they are reflecting back, then wavelength is same, then speed is same. That's why the gap between these two lines, in between two lines, that gap should be same when we are drawing. And when we are drawing these wavefronts, look, the wavefront and the incident wave perpendicular, okay, making 90 degree. Is it clear?
Yes, sir.
Look, these wavefronts given, they are 90 degree with the incident wave. That's why when will be reflected ray, the wavefronts you are drawing, those will be also 90 degree with the direction. Okay, now I am sending you one diagram. That one will help you to draw. In our group, I am sending one, and also I will draw there. Then you draw. Huh? I'm
Okay, sir.
sending you. Just a minute. I'm finding it. Hmm, from here. So you got it, Monica?
Yes, sir.
So this way we should draw the reflected wavefronts where we have the gap between two lines, two wavefronts. Those are uh, similar like before. And when we are drawing the reflected waves, you see, we have, I just sent you this one here. Okay, so when we are drawing this, you see the gap between is same and the angle I is equal to R. We maintained it. And this one is normal, right?
Yes, sir.
It's clear to you now? You can draw?
Yes, sir.
Okay, do it please.
Done, sir.
Very good. Now we are done with question 2. We are done with question 1. We are done with also question 3, right? The till here. Okay, now this part, B. Can you read and tell the answer?
As the wave passes into the shallow water, state what happens to the frequency. It remains the same.
Very good. Then speed.
Um,
If it is going from deep to shallow, speed will be
decrease.
decrease. Excellent. Well done, Monica. So write it.
Okay, thank
Look, practice makes a woman also perfect, right? Not only men,
you. Yes, sir.
isn't it?
Yes, sir.
4A we did, right?
Yes, sir.
And this one, can you read?
Transverse wave.
Hmm.
This water wave is a transverse wave. Explain what is meant by the term transverse wave motion.
Very good. So previously, in our last answer, we got, you see, they were that time saying about ripple tank, right?
Yes, sir.
That's why we wrote their transverse mode. Now they are especially asking us. They already told that it is in transverse motion, and they are saying to explain it, right? What is meant by the term transverse wave motion? So uh, here we have 3 marks. We have to arrange it in 3 points. We have previously 2 points. Now we have to increase another point by explaining what is transverse. Okay, is it
Yes,
clear?
sir.
So what we
Yes,
have to
sir.
do? Your previous answer you wrote. What wave in triple tank is the transfer of energy. Now you will write uh, here they wrote the question the way transverse wave motion. So you will start your answer this way. Transverse wave motion means I am writing transverse transverse wave motion means transfer of energy. Transfer of energy by the vibration, particular vibration, right? Perpendicular vibration of the particles by the perpendicular perpendicular vibration of particles without transferring matter, right? Without transferring matter. So here we only included one thing extra, that is the particles vibration is perpendicular. Okay, this one for getting
Yes.
another mark. The other ideas we got before also, that is transfer of energy without transferring matter. We mentioned it in previous question. Okay, so please take the snap also for this and send it to our group. Okay, read,
Then, sir,
read please.
draw a diagram that represents a transverse wave traveling from left to right across the page. On your diagram, label the wavelength and amplitude.
So this one is very simple question, right? Just you have to draw one wave, and in the wave you have to label wavelength and amplitude, right? You got many questions here where wavelength and your amplitude is labeled, and also in our notes we have. In our notes also we learned how to draw the wavelength, how to draw the amplitude, right? Isn't
Yes,
it? So
sir.
it is our amplitude, and here is our wavelength. uh, Crest to crest. So in the same diagram, now you will label both, right?
Yes, sir.
So you draw one diagram here, like before we got here this way. We have this is our wave, right? And
Yes, sir.
you draw one horizontal line here. Of course, your drawing will be better, right? Because
Yes,
you
sir.
are using ruler and also you will use the pencil. So this is our amplitude, right? This part.
Yes, sir.
And from here to till the
Wavelength.
last here till here we have the wavelength. Okay, so here we'll write wavelength, label wavelength, and here you label amplitude. Is it clear?
Yes, sir.
So wavelength is from here to here till here, the whole part is wavelength, huh? You can add more here, like from here I completed the labeling here. Yeah, wavelength, and this is our amplitude. Amplitude also this one, right? The lower part we can say also this one is also amplitude, right? So amplitude is this one and this one both, right? Isn't it?
Yes, sir.
In one complete wave we have two amplitudes. One is for crest, another one is for trough.
For trough.
Yeah, clear.
Yes, sir.
Then we have question number 5. You are going to school, or like going to school means you are having online classes in your school,
No, sir.
or you became private.
I
Hello,
go to school, but our school isn't holding any online class.
your school is not holding any online class. Oh, how many students are there in your school?
I don't know.
Okay, in your class, like class 9, how many students were there?
34, I guess.
34. So 34 students, you have only one section, or you had
No, we
more
have
sections?
two sections.
Two sections. So in your section, it is only for girls or both girls and boys mixed?
Both, both of them.
Both of them. So you had two sections, and these two sections are divided according to the group, like science group, commerce group, this way.
No, everyone is
Mix.
out there science,
Mhm.
science mixed.
Mix. So around 60 students, like in your class 9, you had 60 students, right?
Yes, sir.
Okay, okay, got it. Now question 5, huh? Read.
Number 5A. Figure 5.1 shows a transverse wave. Four distances A, B, C, and D are marked on the wave. State the letter that shows the amplitude of the wave.
Yeah,
A,
okay,
A,
correct. Very good. So
B,
which one is
C,
wavelength here? Wavelength?
C.
C, very good. Then what is B?
What is B?
B is half of the wavelength, right?
Yes, sir.
And what is D?
It's a full
It's the
amplitude.
double of amplitude, right?
Amplitude. Yes, sir.
Double of the amplitude. So you should also know what the other things are showing. Then B, part B, read.
State the meaning of the term frequency of a wave. The number of complete waves per unit time.
Very good. Have you written?
Yes, sir.
Hmm. And C, continue C.
A long spring is fixed at one end as shown in figure 5.2. The spring is moved towards and away from the fixed end repeatedly. The compression and rarefactions on the spring at a particular time can be seen. State the type of wave in the spring. Mm,
So it's written here compression and rarefaction, right?
Yes, sir.
So compression rarefaction means it's going forward, backward, right? Right and left.
Mhm.
And energy transfer direction, you see, it's written here direction of wave travel. So what type of wave it is? Longitudinal or transverse?
Longitudinal.
Very good, very good. So we understand now what is longitudinal and what is transverse. The next one,
Transfer. State one other example of this type of wave. Sound waves.
excellent, excellent, wonderful. Then part three,
Use the scale in figure 5.2 to determine the wavelength of the wave in spring. Wavelength. mm,
yeah. Wavelength
1
means
meter.
crest to crest or trough to trough, right? So
Yes,
which
sir.
one is your showing here compression? The black one, right?
Yes, sir.
And the other part, you see, that is expansion. So we have one technique here. I am showing you the one which one is compression. That one is for crest, And the one which one is for rarefaction, that is your trough, the middle part is crest or trough, right? Now you know
Yes.
wavelength. What wavelength means? Crest to crest or trough to trough, right?
Trough to trough.
Now from here we can get the distance between two crest, because crest is more easy to get the middle point, right?
Yes,
Isn't
sir.
it? That compression part, this is our crest, right? So from here we'll draw one line from the middle, okay? From the middle point you draw one line from here this way down, this way, okay? Is it clear? Then
Yes, sir.
another one you draw from here this way down, okay?
Yes, sir.
So now you see, for 1 meter we have 10 lines, isn't it? Then each of the
Yes,
line
sir.
will be 0.1 meter. Then here we have 1, 2, 3, 4. Then here is 5. So this arrow is coming in between 4 and 5, right?
Yes, sir.
So we can write here 0.45 meter. Label here 0.45 meter. Okay? Label here. Where you got that arrow, there you write 0.45 meter. Now, for this part, you have after one, we have 1, 2, 3, then here is 4. So it's coming 1.35, right?
Yes, sir.
For my one, I am getting this. You check also your one, what you are getting. So it's coming 1.35 meter. Now, the distance between crest to crest, to get that, we have to subtract, right? Isn't it?
Yes, sir.
So if you subtract 1.35 minus 0.45, that's giving you the wavelength, right? Wave length equals 1.35 minus 0.45, and what is the answer coming?
Um, Wait a second.
Yeah, I'm waiting.
1.35 minus
0.45
0.9.
meter. But in the
Yes.
answer line,
Mm-hmm.
the answer is given in centimeter. The unit is given in centimeter, so you have to multiply with 100.
Times 100. 90.
It's 90. I wrote, you see, I wrote here 0.9 meter. You also write 0.9 meter equals
90.
90 centimeter. Is it clear?
Yes, sir.
So take a snap and send to our group. Huh? Done, Monica?
Yes, sir.
So our worksheet is done,
Mm-hmm.
completely done, right?
Yes, sir.
And after worksheet is done, we will have a test. Okay, we will have a test on this topic. Today our time is over, and also for taking the test, you need some preparation to revise, isn't it?
Y- Yes, sir.
So our makeup class is over. I will give you the test paper, then you will be ready. So in between week, like our class is next Thursday. So before Thursday, any day, like tomorrow is Sunday, then Monday, Tuesday, Wednesday. These 4 days. Out of these 4 days, any day you can take the test. Okay. So you make a
Um,
plan and tell me your plan when you are going to take the test. Then I will give you the link for the test in Google form. Okay.
okay.
Is it clear?
Sir, how about the Sunday?
No problem. I have no problem. Like tomorrow, when you are ready, you just give me message. That then I will give you the link in the Google Classroom. I will give you the link. In today's class comment, you will get the link. Okay. Is it clear?
Okay, sir.
Like today's class, you see, I mentioned here about the test. You see, today's class posting you saw, right? Here, you see, I wrote here makeup class complete, solving worksheet on topic 13. We are done, and test the test on topic 13. So here I will give you the link. This comment place. There I will give you the link. Okay. And
Okay,
when
sir.
you are ready, just tell me. Then I will open it for you. You just take the test that time. And
Mm,
after submission, you just give me a message in our group that yes, I'm done with test on topic 13. Then I will send you the score. Okay, after checking. Is it clear?
okay, sir. Yes, sir.
Okay, so thank you so much. Huh?
Sir,
Yeah, yeah. Tell
what
me.
happened to Mahikan?
Yeah, Mahi Khan, maybe he's sick. I am not getting. I also called his father, but he did not receive. Okay,
Um,
so you do your part. If he comes again, then we will do it for him also. Okay,
okay.
because the
Sir,
recording is there, so he can learn the miss notes from the recording, right?
yes, sir.
So he will finish it from the recording, and after he is done, then he can, if he says he's ready, then I will take his test.
Okay,
Okay.
sir. Yes, sir.
And thank you so much
Sir.
that you are asking about your fellow mates. It's a good thing, right?
Yes, sir.
Okay, okay. Thank you
Um,
so much. Thank you. Allah Hafiz. Huh?
thank you, sir. Allah Hafiz.
Hmm.